Hello, good evening, or good afternoon, or good morning, whatever time it is. This is the week 6 recap video. I skipped out on week 5, and I apologize for that. I might make that video, but let's start with week 6, right? Keep it current. This past week, did a few things. We covered our unit assessment, so that will be due at the end of the unit. Um, we did some more work with the stoichiometry and quantifying reactions. Finished off lesson 2. Started working on limiting reactants and yield, and kind of started the practice on that assignment. I didn't get all the way to it. So this past week, 2 assignments were due: stoichiometry and quantifying reactions, as well as weekly reflection number 6. So what I mean by that, there have been 5 weekly reflections so far, and that was in this past assignment right here. For this new set of weekly reflections, you're going to have eventually 3, right? One this past Friday, another next Friday, and one more the Friday after that. Weekly reflections tend to lose value as time goes on, so after a certain point, there's only so much you could reflect upon. Okay, so what do we talk about on our first day? We talked about your unit assessment, which is careers in chemistry. Now, for this unit assessment, we are talking about careers in chemistry because this unit covers a good chunk of what chemistry is about. And so what I'd like you to do is see how that's applied in, real life through actual careers. And so you'll be writing either a Google Doc or a Google Sheet presenting the information that you gather. If you're doing a Google Doc, double space, 12-point font, right? At least 2.5 pages. Google Sheets, present all the information in an appealing way. At least have an image every other slide. Now, what you're supposed to do, go to this website, acs.org/careers/college, and you'll go through all these different websites, all these different careers. Answer the following questions here, and then pick 2 of the following questions here and answer those. Now, some notes about this. Don't plagiarize any websites, right? Quote them, cite them, but don't plagiarize. Use a variety of sources. Glassdoor is a great site to confirm some of the information you see here. Other job sites like government sites or Indeed are other great places to look up some information about a job. After you're done, make sure you have a reference page and or slideshow, or a reference page and or slide, and make sure you cite the websites properly. If you can't do that, use the link here to help you cite some things. And there's a rubric attached to this thing here. So I'm going to pop it up. Really a standard rubric, 5 sections of grading, 4 out of 5. Fun fact about the ACS website, though, you could go through and actually message some of the people who are involved in these careers. So, for example, if I'm looking into forensic chemistry, I can message our group, or Leah Nemitz, right, FBI agent, toxicology specialist, and these are actual people you could end up talking to. Good stuff. All right, what do we do next? We talked about our practice on stoichiometry, so let's go ahead and go again. And so I'm not going to spend too much time on this because I have a separate video made for this section. However, what I will say is that we did do a large amount of this in class, right? In this example here, for example, we did number 11 kind of. Instead of 85.2, I used 120. And so it's up to you to plug and chug, right? Do that work, see how you do it. The way I've been describing it lately has been, if you know how to turn feet into inches, you're gonna eventually figure this out. It's the same process. Molar mass, lets you convert grams into moles, or moles into grams, either way. The mole ratio lets you convert moles of whatever chemical X, into moles of chemical Y. And so if you know where you're going to end up, in this case, we are going to end up in, we start off as oxygen, we're going to end up in water. Mole ratio lets us turn moles of oxygen into moles of water. And finally, the mole itself. The mole itself is a conversion factor that lets us turn moles into particles or atoms. And so 1 mole will always equal 6.02 times 10 to the 23 atoms or particles. So, not spending too much time on that. For lesson 2, we did this together in class for the most part. And what it is, we are checking out 2 different reactions: magnesium burning in air versus calcium chloride and sodium carbonate mixing in water in a bag. And so we start off with this. What are the 5 major signs of a reaction? We have the 5 major signs: temperature change, color change, bubbling, smell, state of matter change. Those are 5 major signs. It's up to you to explain how you think reactions are different in the products formed between a closed and open system. And for part 1, we measured our magnesium that was burning before and after. 0.12 grams is what we started with. After measuring it, it was 0.9 grams. We lost about 25% of our mass somehow. And so we asked, what was the evidence that a reaction occurred? Well, we had some lights being made, we had some smoke changes, we had some temperature changes. And how was that happening in real time? Well, in real time, your magnesium particles, right, the little balls of magnesium that exist, are colliding with oxygen particles. So, how did the mass compare before and after? And explain why some of the mass tend to just seem to disappear. We have 0.12, now we got 0.9. Where did 0.3 of the mass go? Okay. Let's see. Let's not do that. Okay. So for numbers 1 and 2, or for number 1, same deal. Well, how do we know evidence occurred? For number 2, though, we're comparing the mass. Right, for this section here, where we combined 2 white powders into some water, the mass was basically the same. What changes could be made? Personally, I don't think that many changes need to be done. However, you could always do better. Maybe you could cap off the bag with an actual seal, right? It's kind of annoying having a Ziploc bag. Maybe a jar would have been a better choice. Now, for number 4, we talked about rust and why rust seems to gain mass. And I asked you guys, and it seemed that with water being added to the equation, the metal absorbs some of that oxygen, and so you got a combined mass going on. And that's typically why your mass will tend to increase, even though nothing's being created or destroyed. All right. So for number 5, you want to ask yourself, why does it seem sometimes that the total mass is different than what you would expect? Our first instinct is always human error, right? Measurements were done incorrectly, calculations were done poorly, equipment was unusable, right? Human error. Or sometimes products just aren't collected. Sometimes if you're making a gas, some of it escapes. Okay. Now, that takes us to a note here in limiting reactants. And so with limiting reactants, we're back to talking about reactions, but we have limits to what we could do. It's like making a sandwich with 2 pieces of bread and not enough turkey, right? You've got some of your material, but not enough. So if you ever wanted to open a restaurant, for instance, this comes into play, right? In your restaurant, you want to have enough ingredients to make each menu item on your menu. However, if you don't have enough, you can't make some of your menu items, and now your place gets bad reviews. And so this is what chemists do. We want to make sure our reactions go to completion. We don't want to have extra things left over. We don't want to have extra reactions left over. We want to make sure everything is just right. And so the question was asked, which would burn longer, a fire in an open room or a fire in a closed room? And so the closed room would burn, well, it would burn itself out because it just eats up all the oxygen, while the open room would burn all the way down to ash because oxygen is there aplenty. Now, for this question here, we got 75 pieces of bread, 200 pieces of turkey, plenty of cheese, and it takes 2 bread, 4 turkey, and 1 piece of cheese to make a sandwich. And so I asked you guys, which one's your limiting reactant? And so just some quick math. You got 2 pieces of bread. If you have 75 pieces of bread and 2 pieces per sandwich, that's about 37 sandwiches, more or less, 1 slice left over. You have 200 slices of turkey and 4 slices of turkey per sandwich. That's 50 sandwiches worth of turkey you got. And so 37 sandwiches for the bread, 50 sandwiches for the turkey. Our bread here is our limiting reactant. And so, because that is the case, bread is our limiting reactant, turkey is our excess because we're going to have leftover turkey. And so our turkey will spoil because it's excess and we didn't take care of the bread, right? We don't have enough bread. And so turkey spoils. Fun stuff. Now, this is where it gets really fun. We've got different amounts of each of these chemicals. 48 grams of magnesium, 39 grams of oxygen. I'm quickly running through this because I've done stoichiometry in its own separate video, and there's no change here. What we got to do is we got to figure out how much magnesium oxide, 48.6 grams of magnesium, and 39 grams of oxygen produce. And so we need to set up our equation twice. So molar mass, let's see, switch between grams and moles. And so we need the molar mass of oxygen, we need the molar mass of magnesium, and we need the molar mass of magnesium oxide. Basically, every chemical in that equation, we need its molar mass. We need the mole ratio between magnesium and magnesium oxide, as well as oxygen and magnesium oxide. Okay, and so we do this equation. And so magnesium, if burned, will give us 81.2 magnesium oxide. 39 oxygen will give us 97.6. And so here's the fun stuff. We could go back to lesson 2 and see, oh, okay, well, this much magnesium produced almost double the amount of magnesium oxide. But in our lab, when I burned magnesium, I produced 75% of my magnesium, which is not enough. I should have gotten so much more. And so now I could go back and think about, okay, where are my errors located? Where did I mess up? Why is the reason my yield is so low? And this takes us to the next part here. So before we get to that though, we gotta figure out which one is the limiting reactant, and we do that based on which one produces the lower amounts of our product. And so magnesium produced less MgO, it's our limiting reactant. Therefore, the other one, oxygen, it made more, and so that's our excess. Do it again with different amounts of each, 35, 35. Now again, we see that magnesium produced less. There's a reason for this, and it has to do with the molar amount that we use, but that's getting ahead of ourselves. Don't want to go too far ahead. All right, now, percent yield. Percent yield is just how well was your experiment. Did you produce more than what was expected? That never happens. Or did you produce slightly less than what was expected, which is honestly more common. However, sometimes you forget to dry something and now it's wet, just like hair after a shower. So it's wet and you measure it and it's very heavy, and now your percent yield is 300%. and you think yourself a chemistry god, but that is untrue. More likely, you just forgot to dry it off, and now your products are wet and probably useless. Now, for percent yield, it's a fairly straightforward math equation. You have whatever you actually got on top divided by whatever math, um, whatever you should have gotten. And so we should have, in this question here, we should have gotten 1.61 grams of magnesium. We actually got 0.988. And so our percent yield is just those two numbers divided times 100, 61.4%. And many things could alter the yield of a reaction, the timing of it, right? Maybe you let a reaction go on for too long. Boom, your product's been reused as part of something else. You miscalculate. That happens often enough. Or you measure something incorrectly, right? Three people will measure the same jar of water and they'll measure three different numbers. Unclean equipment sometimes occurs. You don't notice that you didn't wash out your glassware thoroughly. That might introduce some random chemicals into an experiment. Typically, though, your sources of error are going to be coming from either your guys' measurements or the chemical source, which is when products tend to react and reform into the reactants. And that does happen. Right? Imagine breathing in a room with a tree. You would imagine it would choke up with oxygen, or carbon dioxide, but the tree is there, and it's taking the air carbon dioxide and turning it into oxygen. All right, so that will be it for the recap here. We kind of breezed through it because this is a recap. I'm trying to cut these down in time. So hope you enjoyed. If you have future questions, let me know via Schoology message or Remind or through email. All right. Have a great rest of your day. Bye-bye.